Hi everyone, we are still discussing descriptive statistics and we're going to focus on quantitative data in this video. More specifically, we will investigate measures of central tendency. Among the measures of central tendency, there is first and foremost the mode. So the mode is the value, or it could also be the group, whose value has been most often repeated in a study. It's probably the least interesting of the measures of central tendency because, first of all, it may actually not be central at all. And there are a lot of situations where no specific value is really more often repeated than the others. I can think of one situation where the mode is interesting, and that's in Quebec when we talk about the number of children per family, which is almost overwhelmingly always 2. So perhaps I think it's 50 to 60% of families have 2 children. So that would be the mode. The median is the first value that is equal to or exceeds at least half of the ordered observations. Actually, we can think of it usually as the value that splits the ordered observations into 2 groups, those that are below it and those that are above. But more specifically, if data has collected n observations, then the median can be specifically located at the following position. So you would look for the value of your variable in the n plus 1 over 2th position, if n is odd. So if n is, let's say, 17, 17 plus 1 is 18, divided by 2 is 9. So you would be looking for the 9th observation, and that would be your median. Observations have to be listed in order when you do this. If n is even, then you would locate the observation in the n over 2 position, the observation in the n over 2 plus 1 position, and find the midpoint between them. So once again, if n is, for instance, 20, 20 divided by 2 is 10, 20 divided by 2 plus 1 is 11, so you would find the midpoint between the 10th and the 11th observation. All this assuming you've ordered your data first and foremost. The mean, so unlike the mode and the median, the mean, or the average, takes into account the value of every entry. It's not just about where it's ranked, it's also about the value that it takes. If data is presented in exhaustive form, which is that all the values are enumerated, you have the entire list, then the mean is obtained by adding the observations, so adding the xi, the variable's values, and dividing by the size of the sample. How do I know I'm talking about a sample? Notice I have a little n. If the data is presented in a frequency table, then we may also have to remember to take into account the repetitions. So for instance, if xi, so one of the observations, is repeated ni times, then we will have to take that into account. So now the formula becomes ni times xi, so ni repetitions of the value xi, and then you would add that for all the observations and then divide by the sample size. For instance, here's a situation where we have 7 different observations, so number of children, 0, 1, 2, 3, 4, 5, 6, so those are your xi, but they don't appear in the same amount with the same amount of frequency. So 0 children occurred 87 times, whereas 6 children occurred 9 times, so they don't have the same weight. So in this case, we would have to use the fact there are repetitions of the same observation. So 87 repetitions of the value 0, 136 repetitions of the value 1, and so forth. And then we will divide, once we've tallied up the sum, by the sample size, which is 500. In this case, revealing an average of 1.778 children per household. If data has been grouped into classes, then we can only approximate the mean by considering all entries within a class are equal to its midpoint. In other words, since we don't know where the individual values are because we've done some grouping, we're going to take the middle of the group as a replacement for the x's. So notice how in this formula, what used to be called xi has now become a ci for the center of the class. In the above, so we have all of these different formulas that we've shown, and the notation would change a little bit if we had been discussing a population. So little n would have become a big N, and we would use the letter mu rather than the symbol x bar for the average. So you'll see in future courses also that the Greek letters are usually used to represent information about a population, whereas Roman letters, like x bar, reveal information about a sample. So in terms of centers of groups, here's an example of that. So we have a continuous variable called salary, which we've grouped into intervals, all of which are of size 20,000 in this case. We know that 25 individuals are found in that first group, but we don't know how they are distributed within the groups. So in each of these cases, we will take the center of the group as an approximation. So 25 repetitions of 10,000, 10,000 being the center of the first group, and 87 repetitions of 30,000, the center of the second group, and so forth. And once we've tallied these totals, then we divide by the sample size, 245. Once again, in this example, we have lowercase n's because we're talking about a sample that has been collected, and x bar, meaning that the result is the mean of that sample. Notation would have to be different in the case of a population. In other words, for the mean of a population, the formulas would actually have this aspect instead. Notice how now we're using Greek letter mu for the average, uppercase N in our division for the sample size. Same goes if we have data that was summarized in a frequency table and have to take into account repetitions. And we also have the case of grouped continuous data where centers of groups have to be replaced. So the formulas are very, very similar. They're actually identical aside from the notation, which explains to the reader that we are dealing with a sample in one case, or in this case, population information. Excel possesses integrated functions that will calculate the average value of quantitative variables from a data file. So in a data sheet, you will see under the FX button, which is usually top left of your screen, it will give you access to the list of integrated functions. And if you go into the statistics category, and I apologize for the French because my Excel version is in French, sadly, in statistics you would scroll down to the moyenne function, or in English it would be called the average function. So this will open up a window where you can choose in which part of your file you wish to calculate the average. Once you get used to using Excel, you will more often than not just type in the function. So equals moyenne, and then select the range of the values that you are trying to calculate the average for. Or in English, equal average of, and between parentheses, where you're looking for. Same goes for the median, where again, under the FX button, you can scroll down in the functions that are integrated into Excel and find the median function, and then you would just have to highlight the range where the values of your interest are located in the file. Or simply type equal median, and between parentheses select the region for the variable that you are calculating the median of.